All right, everyone. This is a response to a bunch of questions one of your peers has requested. This is page 376 of our textbook, question 7, specifically D, question 10, and another question that I don't know where they got it from, but just a confirmation that this approach is okay regarding the dot product. Okay, so let's get to it. Question 7D. It says vector u, v, w are presented in Cartesian form. Evaluate each of the following if possible. If it is possible, explain why not. Question D is vector u added to vector d, v dot w. So in this question, you remember distributive property and the idea of associative and commutative, blah, blah, blah. When you have an addition and a product, just like BEDMAS, we need to resolve the product first before anything else. Okay. Now, even here, notice how by distributive property, we're allowed to do the dot product of this vector onto this and that vector, and then we can subtract it after. Same idea, right? So, but if I were to follow the brackets, that happens first, and if we actually knew what that vector was, we can dot product with this one. It just follows BEDMAS. So let's resolve the dot product first. In doing so, you remember a dot product produces not a vector, but a scalar. So this is like saying the vector u is going to be added to some real number. Now, you may not recognize something like this because we've actually never done it before. Why? This is actually not possible. Until now, anytime we added, it would always be some scalar plus a scalar or a vector plus a vector. It needs a direction. The only time a vector and a scalar would associate with each other is if we are taking some vector and we're multiplying it by 3 times the amount. In other words, vector u becomes vector 3u. In other words, if you have an addition with a vector with a scalar, we don't have an answer. We can't give you one. Therefore, this is not possible. There's your solution. Okay, a vector adding with a scalar. Not possible. Question 10. Find a vector that is perpendicular to vector u and verify that the vectors are in fact perpendicular. There's a couple of ways you can verify this, but the idea is we need to find if this is vector 9, 2. So if this is vector u, something like that, we need to find vector v that is perpendicular. How do we confirm that? Well, the only time angles are involved with vectors, or rather angles can be somehow associated within two vectors, is by dot or something called cross product. Right now, the dot product is all you know. And 7.3, it's about dot product. We know, let's say we have vector u, and then we do a dot product with vector v. So let's pretend that's our answer. The answer has to be a 0. By formula, we also know the dot product is the component of vector u in the direction of vector v multiplied by the magnitude of vector v. In other words, this has to be 90 degrees, which means the entire thing has to equal a 0. That's it. So what can I do to make u dot v into a 0? This formula doesn't help us. However, the dot product we also know is the x value of vector u multiplied by the x value of vector v plus the y value of vector u multiplied by the y value of vector v is also a definition of the dot product. So let's fill it in. The y component is a 9 multiplied by something plus the y component of vector u is a 2 multiplied by the y value of something. And that has to equal a 0. So 9 times something plus 2 times something has to be a 0. And essentially, they could be anything as long as it equals a 0. So I am going to cheat, in a sense, by making this and this equal in quantity. How do I do that? Why can't I just make the positions different? So if the x value was a 2 here, 9 times 2, that's an 18. Since this is a 2, I'm going to multiply this with a negative 9 to create a negative 18. Long story short, vector u could be 2 comma negative 9. Is that the only one? Of course not. What if it was 9 times a negative 2? In other words, I created a negative 18. Then this could be a positive 9 to create a positive 18. And so my vector v that is perpendicular could be negative 2 comma 9. And any scalar multiple of these two vectors are also acceptable. But did you have to do that? No, not necessarily. Okay, and that's it. Is there a way you can calculate this without algebra? Sure, I suppose so. You could interpret vector u, right here, the direction of vector u, as the slope. The slope would be rise over run, right? 2, 9. So if that's the case, what is a slope that is perpendicular to 2, 9? Negative 9 over 2, which means this could be a run of 2 and a rise of negative 9, or a run of negative 2, which makes the rise a positive 9. Right? There's a variety of ways you can go about this. I feel like a logical interpretation and both a algebraic interpretation are both very much acceptable. So think about that. Last question. Again, I don't know where this is coming from, but let me answer, or let me see if I can confirm this solution. Given A is 3, 1, yes, that's about right, and B is negative 4, 6, these are points, not vectors. Determine the angle between vector A, B, and the positive y-axis. So it's looking for the angle here or here, but because of parallel line theorem, yeah, I could just figure that out. Okay. And so if my vector AB is, let's see, a b minus a, that's negative 7, b minus a, that is a 5. And my vector, sure, let's do this. Vector in the y direction is going to be, you know what, let's use proper terms. How about I use the unit vector j, which is automatically a vector in the horizontal, vertical direction. What is the angle between these two? Right. Looks like the answer, the dot product, they decided to apply the geometric formula to it, which is great. You can get the quantity from here. Negative 7 squared plus 5 squared is 49.25. Good. And the magnitude of y, they decided it was 0.5 for an arbitrary reason, no real good reason, just 0.5. So the magnitude is root 25, okay. And then cosine theta. There's nothing on the other side of the equal sign, so they used a Cartesian, I guess, cosine law formula for the dot product, which gives you negative 7 times 0, 5 times 5, 25. So 25, divide, 0. Yep. The answer looks totally correct. Right? My answer might be slightly different here because I would use a more simpler number, but the angle that we get at the end of the day will be exactly the same. So good work. That looks good. Hope this is helpful. Keep the questions coming, and I will see you in the next one.